I'm CK. Tonight we've got a kit that I think will be a combination of electronic assembly and mechanical assembly. It's a little LED desk light from MiOYOOW. I don't know if I'm saying that right, of course. And I've done a bunch of their kits. Most of them are usually pretty good. We'll see how this one goes together and whether it'll be useful in the end. Hope you enjoy the video. Let's open the box up. QR code probably has a build guide behind it. A bag of electronic parts. We'll dive into that in a bit. First we'll look at the big bits. Here's a little gooseneck. Looks like it may have... No, I think we're going to have to thread the wire through it. It's just got the metal conduit inside this plastic, but it seems to move pretty well. That's nice. Excuse me. Here's the base. I wonder how that goes together. There's little holes in there as if, oh, I see. It's going to go something like this. It's going to plug in there. Yeah, the dogs are there. And there's a connector or some cable that will go through. Here's some contacts here, which I guess this is probably a capacitive sensitive switch. There's the bottom plate. So in the end it'll look somewhat like that. Here is the thing falling over, and after I get it away, go away until it's your turn. It'll be a little while till it's your turn again. Mechanical light pieces. Here we've got, looks like a big old capacitor. Oh, huh. Two things. Oh no, this is a battery, MS18650, 1200 milliamp hour, 3.7 volt. Nice battery, standard. Here we've got a little mini board which has a couple of pin headers, and what I'm going to assume here, I believe this is the charging circuit for the battery we just talked about. Let me get it out of the bag so you don't get reflection and may be able to get a good look at it. Let me get the box ready for recycling. Nothing on the back. On the front we've got... Where's my pointy thing? There it is. Got some resistors, a couple of caps, one transistor, and a chip, which I believe is the regulator chip. Looks like two LEDs here. And then here we've got this pin header, which I believe is going to be connected to the battery like so. And this one is going to go here, and I assume we're going to have an external connector. I didn't look on the box for a connector, on the case for a connector space. I don't see a connector space. Maybe on the bottom here, but I don't think so. But we'll see when we get the build instructions. Interestingly also, there are vent holes, 1, 2, 3, 4, 5, 6, 7, 8, 9 vent holes in the back. That's interesting. I wonder why there are vent holes in the back. So we'll put these aside. Oh, while we're here, may as well power up the meter and see what these LEDs look like. Let me see, where's the cathode side? There's the cathode side. That's a red one. And this one is a green one. So let's call that charging, and let's call that full. At least that's what I'm making the assumption of, having watched enough other people like Diode Gone Wild disassembling power supplies. I have a pretty good idea what's going on in this. So that's fun. I'll put all those components over there because they'll be near the end, and I'll make more noise. Get rid of the ugly bubble wrap. This is recyclable, which is nice. Now let's get another parts tray for all the other bits we're going to be working with here. If we can get the bag open. Yes, success. Another piece of plastic. Oh, I know what that is. That's going to be the diffuser cover for the LEDs. USB charging cable. So if this is battery powered, that's good. It's going to be very easy to move it around. Another 5-wire connector. Don't know where that'll go. We've got a actual paper build guide. Pulse switch with modulation adjustable brightness. It uses PWM to achieve 0 to 100% seamlessly and smooth adjustment of brightness. That's nice. By adjusting the pulse width signal of the power supply. Can also turn off the lamp by potentiometer. Pure white LEDs, 24 pure white LEDs. Flexible lamppost, we saw that. Rechargeable circuit, and a charging module. It's convenient for table lamp to realize wire-free application and charging, which is pretty nice. Now we'll look at the circuit board. Is this... Well, this is the circuit board. It's a nice circuit board. It's all through-hole plated, which is unusual for a MiOYOOW kit. This has got little serrations. It's drilled through there as if this breaks off. We'll check that later. Again, I don't know what this massive amount of solder points is, because this doesn't go, unless it does. Does it go up in? No, it doesn't fit in there, so I don't know what all those parts are. It doesn't matter. At this point, we'll find out. The other components all have their values listed, which is really nice. Transistors, some integrated circuit, some resistors, 102 cap, another resistor, a couple of diodes. Interesting that they have 2 diodes in there. A 104 decoupling cap, 104 decoupling cap, 104 decoupling cap. And this goes out to the LEDs, and that is the connector that we saw, and I lost already. It's around somewhere. It'll come back to us. Here it is. Yeah, it's this connector. We'll go in there. So that's a nice circuit board. Here is 2-strand wire, which I'm going to assume is going to go up the flex shaft. Now we got a bunch of LEDs, good LEDs. I wonder if there's a heat sink on this. Okay, so this is the LED board that will go in the lamp head. It's not aluminum, it's just composite. So LED plus, LED minus, all the diode polarities are marked. This is a good little board too, again through-hole plated. Got the other electronic stuff. Oh, look at that. Yeah, that's interesting. I'll show you what's interesting in a minute. Interesting to me. Ah, come on, I cannot get these bags open. got a knob and a potentiometer. The knob goes on, but I thought this was all, I thought it was capacitive. It felt capacitive. Isn't it? Isn't that what you say, little guys? You can also turn off the lamp by potentiometer. Okay, so I guess you got both. Where is that? I didn't actually see that. Oh, it's this 50K one right here. And we've got the other end of that power connector. Here's the little chip, and it's a surface mount part on a little circuit board material, so we'll take these pin headers and make our own little chip out of them. It's not uncommon. So our little caps, little decoupling caps, the 104s and the 102, a couple of 102s, a smoothing electrolytic, and there's the transistor and the USB power supply. And a couple of resistors, not much. Resistor time will be very short tonight. So that's not a 50K. It says 50K on the... It says 50K on the schematic, but this is a B103, which would be 10K. But let's see, what's this chip part number? I probably have no idea what it is. It's a RIC something, AIP 665, I believe. Well, that's all the parts. Oh, and there's some small screws to screw it all together. So there's all the parts. Looks pretty straightforward and an interesting little circuit. So we'll get the soldering iron heated up with a new soldering iron tip and put this thing together. Have the build guide up, and it starts with text description of everything, and then all the pictures of each installation, which is really nice, easy to follow along and easy to get it right. And these multiple pads down here don't actually do anything. They're not filled in by anything, which I kind of thought because there wasn't anything to put in them. So the board must be used for another kit too at some point. I mean, you could, well, I'm not going to speculate. There's no traces going to them. So who knows what they're actually for. Someone knows what they're actually for, but that someone is not me. And yeah, I mentioned that I had to replace my soldering tip. My other one finally wore out and started bending in half. Soldering tip lasts me between 6 and 9 months. So just always have spare soldering tips of the ones you like, because if you do a lot of work, you will wear them out. Now where did I put the circuit boards? I cannot put this thing together if I can't find where I put the circuit boards, can I? What the heck? There they are. They were under the parts tray. So we'll do the main circuit board first, and we'll start with our two little 4148 diodes right here. Black stripe going to the white stripe on the circuit board. And something which I always appreciate when designers are able, putting the diodes in the same polarity, so the black stripes are on the same side. Now we'll do two of the 200 ohm resistors. I'm going to see what this, they range out to 196.9 on the one, and 196.5 on the other. So, pretty good. Not necessarily great, but pretty good. Oh, I didn't notice. This one doesn't, but this one has the value listed on the paper, which is nice. If you don't have your resistor color bands memorized, which nowadays there's no reason to memorize your resistor color bands. There are so many other tools to let you find that out real fast. It's just old people like me who still care about things like that. I'm not even speeding up through resistor time because there's only 4 resistors, so you get to enjoy resistor time live today. Pretty special, huh? I'm going to solder all these guys down to reduce clutter for the next steps. Oops. Oh. See, my iron and iron handle and iron cable are set to fall into my hand a certain way, and the tip is not set up for that. I didn't align it right, so I'm going to have to... Well, this is not working, is it? That wrench won't work. Ouch! Yes, the soldering iron is on while I'm doing this. Of course it's on while I'm doing this. So I'm going to get it into my typical position and adjust the bend. Why am I having such trouble doing this? Adjust so the bend is where I like it. Can we good? Yep. Again, you don't have to do that. I could force it, but because I use the iron in the same position every day, the cable gets a set to it, and I've got kind of grooves for my fingers indented into the foam on the iron, so if you do this long enough, your tools will acquire certain sets. Look at this here. I don't know if you can see it on there's a back and forth weave of the trace under there. I'm not sure what that's for. I'll think about that and take a look at the schematic. Let me see if there's anything. I mean, if this, I won't speculate there. Yeah, I'm not seeing that having a particular reason on this kit. I think that again was for another kit. So the board is taking solder very well, as one would hope. Let me trim these leads. We'll put the 102s on. There's one of them. Where's the other one? There's the other one. Again, they're using a 102 going directly into pin 1 here, which is interesting. Where's the other 102? Where is the other 102? I guess they gave me an extra 102. Okay. Put that in the spare parts box. Now we do all the 104s, the 10th of microfarads. And of course disc caps don't have a polarity bias, so don't worry about which way you put them in. I recommend that you put them in with the values all facing the same way, just so you can troubleshoot slightly easier in the future if you need to. And then we'll do the USB connectors, what they want to do next. So I'll get these soldered on the board before I do the USB connector, because that will take a little extra manipulation besides just soldering leads down. Yeah, one thing about a new soldering iron tip is it tends to be much better at heat transfer than one that's been eroded and gotten narrower and narrower over the time. Now we'll get the micro USB connector over here, and as you can see there are two points where the support legs go, and then it's just picking up power from the two power pins on the connector. So we will put this on like so and lay it down flat on the board. And it's not going to go flat on the board because the caps are keeping the board, the disc caps are keeping the board from going flat on the solder pad, so I'm going to have to support it. And of course, because it is it's running away from me, because it's a metal connector and I'm going to be supporting it with my finger while I solder the support leg, I'm going to burn my finger as the heat transfers. No, I didn't. Huh. I usually do. I don't usually mind because I've burnt my fingers with soldering iron so many times over the decades. So the two pins are on those flat pads. I could have tinned them. I chose not to because they're a little I didn't want the pins to rock while I was putting it on, but that went on just fine, and it's very secure. It's pretty secure. I'm not going to say it's very secure. Now we build our little platform for the, oh, that's a 555 timer. I'm sorry, I forgot to mention that. That's a, I can't see that on the, I wonder why they, oh, I see. Look at this. I didn't even realize that. They threw a socket in here, but then I guess they found that they couldn't find or didn't have a 555, so that wasn't a 6. That was, it's really hard to see. AIP 555, so this is just a 555 timer. And I guess they probably initially planned this to have a through-hole type 555 chip, and then probably somebody's boss came along and said, we can't find enough 555s at the price we want, so we got these little surface mount 555s, make a little board and do that. You know how that goes. You're 90% through the project and somebody says, got to make a major change, and you deal with it. And I'm going to solder one pin on each of these, if I can get it connected well. So that's one pin on each. Now I'll look to see if this fits on it well. That's all we really care about. Yes. That the pins are perpendicular and parallel, like so. So they can go on just like that. I'll push it all the way down. Now we'll do all the rest of the pins. Do the pins on the bottom first. Use up this last bit of solder. See, I didn't get the tip right still. I have to keep twisting it. But if I just leave it in place, then over time the soldering wand cable will flex back to whatever I'm doing. Oops. Can he use this last bit of solder? Yes. Ow! Ow! That did hurt a little bit. But all those look good. Let's solder the top connections. Be a little bit careful here. This is not as bad as some other kits I've done recently, but you are soldering close to a surface mount component, so you want to make sure your iron doesn't touch the component, or more importantly, touch the solder points that the surface mount chip is connected to, because you can dislodge them. This is good board material because I should be, as you can see, I'm being a little sloppy with the solder, and it should be bridging like heck, but it's not bridging because the solder resist material on that mini circuit board is really good and really resisting the solder. Oh, the bend pin. This is the bend pin. Goes on like that, and this will be much easier because it's plastic, so I'm not going to burn myself. That's flat. And then on the little break-off board, we'll put the straight connector in, which I just had. Did I? Yeah, I just set it down on something. And which way does it go? It goes thick side like so. You can see there's a little, even if you don't look at the picture, there are little grooves here on the connector that go to this the little leg slots that they show there. Pretty easy to get correct. Now we're going to put the transistor on here at Q1, flat side to flat side on the silk screen. I won't solder that one yet. And we'll put the big cap in, very clear indication of where the positive and negative leads go. And then we have another install one-piece 3-pin male. That's this little header. Why I'm losing parts tonight, like nobody's business. Okay, there it is. Goes here, and it says it needs short pads PQ if the battery charger module does not need to be installed. So if you're not going to, I think that means if you're just going to use the USB connection, you're going to bridge these two pads here. But if you're going to use the battery, you'll install this pin header. And I'm going to use the battery because I was I've been thinking about it, and a little portable bright desk lamp with 24 LEDs in it will be pretty handy around the shop. Let me double check those. They're all good. Let me do these other 2 leads, 4 leads, whatever. Actually 5 leads because it's got a transistor in it. So the 555 is telling the transistor how long to stay open to get the dimming effect that this does. And that's what the capacitors and the resistors are doing by setting the resistance going into the 555. That's what this guy will be doing to change the pulse width. Okay, what are we doing now? Okay, that. Now we'll put this, what we just had, we'll be tucking this in here. You know, and then we're going to break it off, I believe, because that's what this power connector, this wire connector is doing, is going from this to the main board, and this pot will be poking out through the position here. So we will break this off so it can actually do that. Let me put my solder, ouch, and I just impaled my thumb on the socket I don't need, but it's nice to get an extra socket to have around. Next video or sometime I'll show you my box of extra parts from kits that just grows every day. Every kit. Okay, that's that. Now we're going to get the battery module out, and now we put the battery charger module on top of this pin header that we just put on, and I'm going to support that a little bit with something. What do I have to support it with? I got a little piece of foam. So I'm not sure if the LEDs will be visible. I'm taking a look to see where the USB connector cutout is. Well, there's a USB cutout here, but that wouldn't fit. Oh, it can fit. No, it can fit. Yeah, it'll just barely fit. So the LEDs will be kind of, I don't think they're visible. So it's a generic, it's a multi-use battery charging module. Sometimes it matters whether you can see the battery, sometimes it doesn't. Now that is not level. The pads, I'm not going to shave that down to make it level, so I'll just level it with my fingers, or actually the soldering iron should, soldering iron should, so I'll be able to put that there, then take soldering iron away, and it cools off, and we're all good. Do this one next, so the heat of the soldering iron doesn't melt the one I just did, which would cause it to flop down again. That looks good. Now we snap this bit off where the potentiometer is, because we're going to put that through the top. And now we're done with this board, because there's something that that's marked for that. There's another LED Oh, that's power to the LED. I'm sorry, we'll do that later. That's power coming out, going up to the lamps. So we'll do that in a little bit. But now we're going to make the light board. And these are little LEDs, and we'll give them a little, oops, and of course I dropped one. Of course I saw where it went, which is nice. Let's give these a eyeball. See how bright they are, just from, oh, they're nice. They're nice LEDs. So we'll populate them all on the board. I think I'm going to try and be careful with these to get them really flush. I think it'll be relatively straightforward because since they're all the same height and there's no other components on the board, they should all just lie flat and be pressed flat against. As you can see, I'm kind of alternating how I'm splaying the leads. I actually don't need to splay them that much because, again, I'm going to set it down firmly on the board, and that should keep them in place. So this will be, instead of resistor time today, we'll have little LED time. So I'll mount these all and solder them all up in fast motion with no commentary, and while you're listening to some background music I put on, I'm going to be listening on the WQXR iPad app, FM radio out of New York, classical Symphony No. 2 in E major by Niels Gade out of Copenhagen. I don't know if I've listened to this piece, but that's what I'll be listening to. So LED time is over, and we've got all the LEDs up, or mounted at least. Let's see, I'm going to put my meter in continuity mode and give us a little zap on the leads very quickly. Okay, they all look, there's no resistor in line, so I want to do this very quickly, even though with this many LEDs I'm not too worried about overvoltage, overcurrenting it from a meter, but as you can see, they're all on. They also gave me a spare, just in case. That'll go in my spare box. Always good to have LEDs and the like around. What's the next step? The next step is now to connect the power cable to the board here. So let me take this and clip it apart, like right here. Run the wires back a little bit. So I can get it in my wire strippers. Just a little bit, we don't need a lot. Of course, I'll take the red lead and put it in the positive terminal.
see that. It's just the silver fades in with the silver. It should be good. Yep, solder went all through. Looks like a good solder joint. Now we'll do the negative. If I can get my wires twisted around the right way. And that's all good. Nice. Now, I'm not going to undo this end yet, because now we have to thread it through the gooseneck. And if I cut it open, then it would get snagged inside the little conduit here, which it's already kind of doing. This conduit's not cut real cleanly inside, and I can't really see it. There we go. Feed it on through. Just about 5-6 millimeters at a time. And eventually it'll come out the other end. I sure hope it does. There it goes. Coming out the other end. Let's see how this mounts, okay. So there's 4 little... I've lost my pokey thing again. 4 little pins here, which actually, this one's got a little nub on it. Oh, because there's a little index pin right, there's an index pin hole right here that the little nub on that pillar will secure the positioning of the LED matrix, if I can get it in here right, which I'm not right now. There we go. And where's the little nub? I can see it. I'm not on it yet. There we go. So the little nub is in that hole. Now we're going to take our diffuser, and it's got a little round cutout here to go there. All good. Now we've got, I think all the screws are the same length. Sure hope they are, because if they're not, it just got, no, they're not. These are the little, I think these are the little screws. They're 4 short screws that I'll use. 2, 3, 4, yep. These are, of course, self-tapping. So there's no particular threads to mate with. Do opposite corners first. And just snug. You don't want to gorilla these together. And I know every time I say that, all around the world there are like 50 gorillas saying, look, I can't help it. It's the way my muscles are built. I'm sorry, I don't mean to offend you, gorillas. That's simple, and we've got, if you look at that, we've got plenty of lead on the end. Let's see how much lead we got on the end. We've got, geez, 110 millimeters free at the end. That's plenty to do anything in the future. Now, yeah, we're all at the mechanical assembly phase, as you can note, because the rest of the connections, there's going to be one more solder joint for that cable I just brought in, but the rest is going to be other cables. So we're going to connect these up. hopefully. Yep. I want to double check this because this will go on the potentiometer, and that will work like that. That'll be just dandy. They're keyed, so you theoretically can't get them wrong, but in any human endeavor, humans can, and often do, force things together wrong. It's kind of what we do. Sometimes we learn new things doing it, but most of the time we just break stuff. Now we fixed PCB on the bottom plate with 4 more screws. Here's the bottom plate. So which way does this actually go? Taking a look. Okay. There are again 4 posts, and there are 4 screw holes that go above those posts, and we'll drop it in there. And then I guess the battery will flop in here. Is the battery going to fit in here? I'm sure it does, but it seems kind of thick. Yeah, it'll fit. It'll be flopping around though. I was just about to say I may put a piece of double-sided tape in there, but do I have double-sided tape? I'm sure I have double-sided tape. I just rarely ever use it. So 4 more screws, and we do have some more little screws. Do have 1 more. They gave us 1 extra little screw. Well, that's nice of them. And again, I'm still a little muddled as to why there are all these contact points built onto the board that aren't used. Must have been something that they had planned for this. Now with these long screws, it can take a little bit more force to get them together, but you still want to make sure you don't put too much force on it. And also the USB, as you can see, the USB has got a little notch there that it's going. USB connector has a little notch it's going to. I think I picked up 2 screws. I did pick up 2 screws. Drop 1 screw. Now, I was saying don't push too hard because you'll strip the plastic. You won't. You'll strip these screw heads. These screws are not very sturdy metal. And look at that. I said it was not sturdy metal, and there you go. I busted a screw head off. They're really cheap metal. Okay, well. I busted 2 screw heads off. I didn't even realize that. Golly. Don't even know my own strength. Okay, we're going to have to live with 2 screws holding the circuit board on. Golly, I didn't know it was that. These screw heads are that. These screws are that bad metal. They're made of worse than pot metal. So I'm just going to have to be really careful when I do this. If I feel any resistance, I'm going to stop. But I do want to get it at least in contact, don't I? I do. Yeah, a little more. Hope I don't bust this screw head off. I didn't even notice I had done that other one. Okay, that's going to be good enough. I'm not going any further there. Now, we run the wire through this plate. There's a hole in the center of the plate. And then we angle this up, and I want to make sure it's going in a decent way. Yep. And now we're going to put two screws in here also, and I'm going to be... This one really matters because this is securing the whole gooseneck, so I do have to be careful I don't bust these screws off. Okay. The gooseneck is in place. Hopefully that doesn't bust. Now we're going to we're going to solder our power leads down. Same drill. Oh, by the way, this is the next night from when I started this, and I'm going to check my phone right now because our power has been off. It's March 21st, 2023, and our power has been off here in coastal California most of the day, and I've been running off my house batteries, and they're charging back up. Got down to 50%, now I'm back up to 73% battery. Yay! So, there are two pads here where we'll put these wires. So what I'm going to do is I'm going to put a big old glob of solder on the pads one at a time, and then take the wire and put it on top of the pad that I just put down. Heat it up. Get some good contact in there. Let it cool. There, that one's good. Do the other one. I could go through hole on that, but I didn't want to. I want to get a little more connectivity on it. Do the same thing again. Heat that solder pool I just created. Let it cool. And that's good. Now we'll connect the battery. I do not know if this is charged, so I'm going to turn the pot, all the way counterclockwise to make sure I don't mess anything. I don't have it come on immediately. And which way does it go? It goes this way. Here we go. Now I'm going to see how this captures. Oops. Because I really don't want this battery flopping around. Put this here for a second. Can I shake it and move the battery? No, not really, but I am going to tape it down just because. Get a little piece of electrical tape, and of course I took my scissors inside the house for some reason or other, so I have to use a X-Acto knife blade. And we'll just tape that down so it doesn't flop. Next, we're going to put the potentiometer on, and it's got a little index pin right here. And that index pin goes through, there's a little hole right here to lock it in place. Now get the panel nut and run it down. And tighten it a little bit. Again, not super tight, just enough so it doesn't come loose. Now we're going to mate the top and the bottom. Enough. Now we've got one last thing to do, which is put the cap on the potentiometer. Okay, now let me turn my power light, my overhead light off here. Not that it makes a huge amount of difference. The cameras compensate so well. Let me get I'm going to go USB first because I do not know the state of charge of that little lithium battery that's inside. Plug into the micro or mini USB connector. Now theoretically, one of the LEDs in there is probably on now. But let's power this up. Ha! Ta-da! Ooh, it gets really bright. That's quite bright. And down, and bright, and down. I'm going to unplug the USB connector, and the battery is on. The battery is charged. So there you go. Got a nice little light that I can carry all around the shop. If I want to do close work, that's very nice. It's a very good kit. Had fun with it. Except for the screws being fragile. It's a good quality build. Obviously, as you can see, it works really well as a light can work. And putting it together was a breeze, so I can really recommend this. This is probably a good third or fourth kit for a youngster, simply because the mechanical assembly stuff you may want to help them with. But the mechanical assembly was much less difficult than many I've done. So overall, a very good little product. Hope you enjoyed the video.